right, Mohammed, can you see my screen?
Yes, man, I can see your screen now.
All right. Okay, so from the last class we treated, I think, stoichiometry again. And I asked those that was in the class to let me know what topic they would like to learn in the next class, and I didn't get a response. So I just think we should do some study of previous paper today, like a walkthrough. And
Man, what of my excuse?
what?
More, what about more concept?
Mole concept.
Yes.
Yeah, it's part of
Or
the stoichiometry that we have treated already. So are you like asking me what it means, or is something you wanted to learn?
no, you were asking that you tell some people they should tell you which topic you want to choose today. That's why I wanted to tell you.
Okay. It's what we've already done. So um you can go to the recorded videos and recorded classes and you watch them so that we don't repeat everything in this class all over again.
Okay.
So on the screen we have a previous question, and if you've been studying your past questions, I believe all these things are familiar to you, right? This is one of the previous years, and we're going to be doing it together with you um responding. Okay.
Okay.
Now the first question, as we can see it on the screen, it says how many moles are there in 4.5 gram of ozone? Now it's part of one of the things that we did in the last class. And since the question is asking us for mole, the first thing to do is to ask ourselves, what is the formula for mole? So what's the formula for mole? Do you know?
No.
Mole is represents small letter n. So what formula can we use to find mole, like number of moles? Wait, you said you don't know?
No, I don't know it.
Ah, Mohammed,
Is it mass over mole?
mass over molar mass.
Mass over molar mass, I mean.
Yes. Mohammed, your exam is which day here? Next tomorrow. Mm? So you should study more, okay? I know there are some people that wait for dying minutes and they will still do well in the exam. So maybe you are one of the dying minutes students, but you will still write the exam and you come out well. But it's always advisable to study when you get the chance to. Now, number of mole is given as mass. It's given to be mass divided by molar mass. Now, in your exam questions, when you see certain kinds of numbers in bracket, usually it's the molar mass that is being given us there. Okay. And molar mass for oxygen is 16. All right. And mass is 4.8. That's what they said. 4.8 gram of ozone. So when we see this gram here, it tells us that they've given us the value for mass, right? Now we are calculating the number of moles for ozone. All right, not for oxygen. So if we were calculating for oxygen, we would just say 4.8 divided by 16. Okay, if they said 4.8 is the mass for oxygen. But then 4.8 is the mass for ozone, right? But 16 is the mass for oxygen. But we can use this to get the molar mass, rather, the molar mass for oxygen. We can use this 16 to get the molar mass for ozone. So what's the formula for ozone? This is ozone, O3. So that means if oxygen is 16, ozone will be 16 times 3, because we have 3 oxygens in ozone, right? So this would be 48. So that means um, the moles in moles will now be equals to 4.8 divided by 48, which I believe is 0.1 mole. Mohammed, do you understand?
Not really.
Oh, what part don't you understand?
That was
Okay, let me go back to it. Now, everything has a formula in chemistry. I believe you already know that.
yes, I
Okay.
already
Now, when we see a single zero like this, we know it is oxygen. Now,
yes,
ozone is um um another substance on its own. Okay. Now, what is the formula for ozone? Ozone is made of oxygen. So it's more like one oxygen, and another oxygen. So three oxygens gives us ozone. So three. So the formula for ozone is O3. Okay.
yes, ma'am.
Now we are trying to determine the mole of ozone, the number of mole of ozone. And the formula is mass divided by molar mass. We're given the mass to be 4.8. We already know that it's in the question. But the molar mass, how do we know what the molar mass is so that we'll be able to know what the mole is? We can determine the molar mass by what we are given here. This number in brackets, okay, is the molar mass for oxygen. For oxygen atom, just one oxygen atom. So one oxygen is equivalent to 16 gram per mole,
Yeah,
which is the this 16 here. But ozone is not just one oxygen. Ozone is made of three oxygens. The formula for ozone is O3. Okay, so if one oxygen is equivalent to 16 molar mass, which is 16 gram per mole, as I wrote it here, then ozone will be what? 16 times 3.
grandpa.
Yes, very good. So this will now give us the 48. So our molar mass is not just going to be 16, it's going to be 48 because we are considering ozone, not oxygen. Okay, not oxygen atom. So that's why we have divided by 48 to give us 0.1 mole. Do you understand it now?
Yes, ma'am.
Good. Now the next question says, write the formula for write the formula of the following ions. Now the first one we have hydrogen, tetra also sulfate 6 ion. I believe as a chemistry student, you have seen this tetra also sulfate 6 a lot,
Yes,
right? What's
yes,
the
ma'am.
formula for it? What's the formula for tetra also sulfate? It's more
Hydrogen.
like a compound ion ore. So when we
Hy-
say hmm?
hydrogen.
Yes, the tetrahydrosulfate. I'm asking what's the formula for it? How do we write tetrahydrosulfate 6? This is
It
it.
hydrogen tetrahydrosurfaces everything.
Yes. Okay, everything.
H two
H what?
two
H3.
is like that tetra. I don't know what tetra.
Okay. Now, this tetra also sulfate is a very common ion. Okay, so this is the formula. So it's more like a IUPAC name. All right, it can also be called sulfate. When you want to call it fully, tetra also sulfate. Now, this is it. But in the ionic state, this is how it is written. Ionic state means a substance or a compound that has a charge.
Okay.
Okay, a charge can be positive or negative. So when we see things like this, for example, in your textbook, H, then one positive or negative sign at the top, or one positive or negative sign at the top, that means that thing is charged. That element is charged. Okay, and or
Okay.
ionic. So they call it charged or ionic. Now they are asking us to write the formula for this ion. All right. So tetraoxosulfate 6 is written like this: SO4 2 ion. This is the ionic um notation for tetraoxosulfate 6. Okay, and then hydrogen. How do you write hydrogen ion? Hydrogen ion is written like this. We know that hydrogen has only one valence electron in the outermost shell. Hydrogen is just number one in the periodic table, and so we have it just like this. Okay, so if we are writing hydrogen tetraoxosulfate 6 together, we are going to be writing it like HSO4 minus. Okay, how do we get this? Plus 1 is coming from hydrogen, and minus 2 is coming from sulfate. Okay, so it's now going to be plus 1 minus 2. And in maths, 1 minus 2 is what?
Ma,
In maths, 1 minus 2 is what?
one
1 minus 2 is
minus one.
minus 1. Okay, so that's how we got this minus here. So we don't necessarily need to write the 1. If you want to write the 1, fine, but you don't necessarily have to write it. Okay, so hydrogen tetraoxosulfate 6 ion is written as this. So this other one is just a breakdown of how you can get it. You just get it separately. The hydrogen, you put down the hydrogen, the tetraoxosulfate, you put it down, then you add or subtract, you add up the charge that each of them has. Okay. Now for the next one is also nitrate 3. Also nitrate 1 rather. Okay. Now in this one, also there means the presence of oxygen. Okay. And nitrate there means nitrogen um
I,
coexisting with oxygen. Hello, can you hear me?
yes, ma.
All right. So oxo nitrate now would tell us our nitrogen and our oxygen. Okay. Now, nitrogen is 7 in the periodic table, so it is 2 and 5. Okay, because we are trying to now get the charge of this whole thing. Okay. Now this is also an ion because they said formula for following ions. So we're supposed to write this also in an ionic form. Okay, so that means nitrogen is going to be -3. Okay, that is, it tends to accept 3 electrons. So if nitrogen is -3, and then the oxo nitrate, the oxo there, one oxygen, the one oxygen there would be -2. That's the charge of oxygen. Okay, so it's now totally going to be NO -3,
Minus five. Hello. Hello.
Hello, can you hear me?
I can hear you now, ma.
Okay. So for the nitrogen, sorry.
You were saying -3 -2.
No, please. Okay.
Okay.
Now the also nitrates have to do with nitrogen and then oxygen. Okay. So
Okay.
the charge we are going to get here is a -1. That will be the overall charge. Okay.
Okay. But now why is it -1?
Good question. Now this one,
Hello.
I can hear you. I'm coming.
Okay.
Now this one is telling us of the charge of one of the elements here. Okay.
Okay.
All right. So if our nitrogen is having the charge of 1 and our oxygen is having the natural charge of 2. Okay. So 1 minus 2 is going to give us -1. Now I believe we have been taught oxidation state. So if one is implying that that is the oxidation state of nitrogen. All right. And if the oxidation state of nitrogen is going is 1, okay, and that, let us assume that this charge is not there already, and
Okay.
the oxidation state of um oxygen is -2. So this is implying 1 minus 2, okay, which is equals to -1. So this, when we say also nitrate 1, okay, this one here is representing the oxidation state of nitrogen in oxonitrate. Okay, not
Okay, ma.
necessarily going to be the valency of nitrogen atom when it's on its own. Do you understand?
Yes, ma.
So that's why the overall charge is going to be a -1. Now the next one is name the following organic compound. Okay, the following organic compound, we have CH3, CH3. All right. For a compound like this, we don't just go straight into saying we have 1, 2, 3, 4. And so this is going to be a butane or whatever. But at least we have an idea that it has 4 carbon chains. But still, an advisable way to go with this is to draw the whole structure. Okay, you have been taught organic chemistry, right?
Yes, ma.
So we have CH3. These are CH3. And the next carbon is a CH. Then a CH. Alright. And the next carbon is a CH as well. And the last carbon is a CH3, like this. Okay. So now this is the same thing as the structure, the formula that was written there. Okay, but this is not complete already. Why? Because the second and third carbons are not completely bonded. Second and third, they're not completely bonded because carbon is supposed to is tetra, okay, tetravalent, so it's supposed to have four bonds surrounding it.
Okay.
Okay, now
Yes,
this
ma'am.
second carbon is having just one. Let me use the red. We have one, two, and three. The third carbon, the same thing. One, two, and three. So it needs one more bond. But then there is no more hydrogen that is bonding to them, because if we are giving each of them one more hydrogen each, it will be contradicting the formula here that we are trying to draw. All right. So we're going to give an extra bond. That means there is a double. That tells us that there is a double bond existing between carbon 2 and carbon 3. And so this is going to be boot in. Okay. Or we can say boot 2 in. Rather, but rather we should say boot 2 in. All right. Now the next one. Bame, do you understand?
Ma, why is this boot 2A? Is that the name? Like,
Yeah, that's the name. Is the name because it's the name because boots there tells us the longest carbon chain. Okay, it's four because there are four carbons there that is making the chain. So boots represent four carbons. Prop prop represent three carbons. Et represent two carbon chain. Okay, that's how it is. And then the two there, how we got this two is because the double bond is in position two. All right. So this
okay,
is position. This is the first bond. This is the second. This is the first carbon carbon bond. This is the second carbon carbon bond, and this is the third carbon carbon bond. Now the double bond is in the second carbon carbon bond. That's why we have the two here, position two. This boot here means four carbons, right? Then why is it in? In because of the double bond. So any structure that has double bond in it, it belongs to the alkene family, and so it will always that substance will always end with in. Okay, that's why it is
okay.
like this. Now the next one, we have this. Now when we see structure like this, we can easily see from here and identify a functional group. Okay, even though it's always still advisable for us to draw a structure, but this one is quite easy and obvious. So what functional group can you see here? And Mohammed.
Ma, I don't understand. What kind of functional group?
Mohammed, you've not been reading your books.
Mm,
Yeah, asking what kind of functional. Okay, now let me just draw it. Okay, this structure is the same thing as this. All right, look at it here. We have CH3, then we have CH2, and we have CO and OH. Okay, this is the same thing as that other structure. That what we have in the question. This is called molecular formula, and this is called the structural formula or the structure, one that you tend to draw. Now, from this structure, you know what are functional groups, right? So, what functional group can we see here? Or from here, we can even name the structure already. I'm asking about the functional group because you need that information to be able to accurately name. Okay, that means you've not studied functional groups as well.
Uh,
Now, functional groups are like specific groups that tells you the family that a structure is coming from. So I've done that topic in one of the previous videos, so you probably should go and watch it.
how can I go and watch it?
The class, I said classroom. The um the platform, the Sismo platform.
Yes, no.
So you can send a message on the group chat if you have no idea how to log in. You can send a message on the group chats.
Ma?
The what's her name? One of the admins is going to attend to you, maybe direct you. But that platform that you registered for these online lessons, that's the same platform you're going to see the uploaded videos.
Okay.
All the previous classes have been recorded, and you would see each class based on topics, based on subject. You see them there, provided you register for it. You registered for it.
Okay, my ID start for it.
All right. Now this is the functional group in this structure. Okay. And this is uh, a carboxylic acid functional group. All right. So when we are naming a carboxylic structure, we're going to end it with O8. And then that is to say this is already out of the our struggle. We already have dealt with the functional group, right? So now we have to consider these other aspects. We are not totally done with that, by the way. Now the next thing, the first thing actually is for us to determine the longest carbon chain. The longest carbon chain here should also include the functional group. And so it is 3 carbon chains. So this is going to be a probe. 3 represents a probe, just as 4 represent boots there, right? So we have carbon number 1, carbon number 2, carbon number 3. So it's a probe. Now there is no carbon-carbon double bond, so it's going to be propan. And the functional group I said is carboxylic acid, and we call carboxylic acid as the suffix of oate, so it's propanoate. Now the next question says, what does it mean to say an atom is electrically neutral? Okay, remember I said here, like, okay, an atom can be neutral or charged. Okay, when an atom is neutral, we have something like, for example, oxygen. This is neutral, it has no charge. Now, when oxygen is charged or ionic, it can appear like this. So it's still same oxygen, but one is having more electrons than the other.
The other.
Okay, this one is having more electrons, and this one is charged or ionic. Compared to this neutral electron, this one has less electrons and it is neutral. All right.
Yes, ma'am.
So in in essence, something is electrically neutral when it has the same number of protons as its number of electrons. Okay, and so the overall charge of that atom will be zero. Just as in this oxygen, it has no charge, so it is neutral means it is zero. The overall charge is zero. Okay, but for this other oxygen, the charge is a -2. So charged, something that is electrically charged has proton and electron, they are same. But something that is neutral, proton and electrons are the same. I hope that's what I said earlier. And then something that's electrically charged, the proton and the electron are not the same. Okay, so either the electron is more or less than the proton. So when it is more than the proton, that's when we see negative charge. When it's less than the proton, that's when we see positive charge. All right. So something is electrically neutral when the proton and the neutron are the same. Okay.
Okay. Okay, ma'am.
And we know that proton is positive and electron is the negative part of the atom. Protons are positively charged and electrons are negatively charged, right? You have taught subatomic particles when you were taught proton, electron, and neutron. Proton is
Yes.
positive, electron is negative. So if proton is positive and electron is negative and they are the same numbers, okay, it means that the positive can cancel out the negative, or the negative cancel out the positive, and so we just end up having zero. But when one is more or less than the other, we won't have um we won't have it that one is able to totally eliminate the other. We'll have some balance, which is causing that charge. For example, for this oxygen now, if oxygen proton number is 8, and electron number, if it's the same with the proton, is also going to be 8. But then the proton will be +8, electron will be -8. So +8 -8 is still 0. But with the charged oxygen, proton is 8, but the electron is 10. All right. And so +8 -10 is -2. And so the difference is what makes the difference. Now, the next one is write the electronic configuration of these. So you are SS3 student, right? So this particular one, it's you that will answer it. What's the electronic configuration of magnesium? Magnesium has 12 as the atomic number. So tell me what to write.
Electronic configuration, right?
Yes.
Electronic configuration. Ma, can you explain the meaning of electronic configuration for me?
Okay. Electronic configuration means how electrons are arranged. Okay, that's the simple layman terms for saying it. How electrons are arranged. Now,
Ma
it
is
also relate. Mm?
2, 4, no, 2,
Mm-hmm.
8.
Mm-hmm.
Cause I can't do it off it. Can I use book? Like, can I write it on my book?
Okay, write it on your book. Something that is already obvious there. Anyways, okay, write it in your book. And then you tell me how you got your answer.
Okay, ma. Ma,
Yes.
I got four. Sorry, two,
Mm-hmm.
8, and 2.
Mm.
In the
Good. So how did you get it?
I drew that um those K shell, those shell,
Yes, okay, that's nice.
and
Okay, you
I
now
arrange
place
the
it
atom.
inside. Okay. So what if I now said,
Hello.
hello, I can hear you. Can you hear me?
Yes, ma'am.
What if I now say that this is wrong? The correct answer now is
Ma, yes.
is two, 8, and 4. Do you know why this is the correct answer?
No, ma.
So tell me why if you disagree that this is not correct, tell me why it is not correct.
Because um magnesium have 12 electron, right?
Very good. Yes.
Two in
So
the in two is in that innermost layer, right?
yes,
8 is in the middle one.
very good.
But in my own, 2 is in the last one.
Why must it be 2 that will be in this last one? Why is it not 4?
Because 2 plus 8 is 10.
Yeah.
It will remain 2 share for magnesium. That's why I put 2.
Yeah, very good. Remaining 2 electrons, not shell. Is this
No,
big
it's 2.
circle that they call shell?
Yes, I
This
know.
things
Sorry,
that
ma'am.
yes. Okay, so that is it. You are correct. Now, in this case, you can say that this is a neutral magnesium because the atomic number, which is 12, is the same thing as the electron number. So, if atomic number of magnesium is 12, it means that the electron number is 12. And so, we are going to arrange 12 electrons in this our shells. Okay, that's what electronic configuration is all about. Electronic configuration doesn't arrange proton number or atomic number. Okay, it
Okay, ma'am. But why do you say
specifically
the
arrange. Huh?
But you see, your own answer is 284, right?
No, I was just trying to see whether you will explain better for me. It's
Okay.
282. You are correct.
Okay, ma'am.
All right. Now the next one is sodium ion. Sodium has atomic number of 11. Okay, but then we are not dealing with sodium. Okay, we are dealing with sodium ion. Okay, this is neutral while this is charged. This sodium is neutral while the ion is charged. The neutral one means that sodium has 11 electrons, which is equal to proton and atomic number. Okay, but this charged one means something has changed. Okay, and when an element is now charged, it means that it has either donated an electron or it has accepted an electron. But if it is
Okay.
charged positive, if the charge is positive sign, a plus, it means that it has donated electron. It has donated, that means it has lost.
It has given out, right?
Yes, that's giving out. But when it is negative, it means it has accepted. It's now
Okay.
having more. If it is positive, it means it's having less. That's less of one, less of two, less of three. Okay, so this sodium, it means that it has donated one. So since sodium is 11 before, okay, 11 electrons before, now sodium has donated one. Now it means that sodium is now 10.
10.
So to write the electronic configuration of this sodium ion, it's now
Will
going
be
to be what?
2
Yeah,
and
very good. 2 and 8. Now this next one, I want you to do it on your own. This is nitrogen ion.
now.
Yes.
I should do something by my own.
Yes, do this one on your own. The 7 there is telling you the atomic number or the electron number for a neutral nitrogen. But this nitrogen that they want us to write configuration for is having a charge of -3.
Ma,
Yes.
I have two
Mm-hmm.
two
Two
eight
words.
eight. Hello?
I can hear you. That is that all?
No, 2882.
2882. How did you get it? Because this one now, this 2882, it means that you are saying that nitrogen is 2 plus 8 plus 8 plus 2. Okay, this is like 18, 19, 20. So this means nitrogen has 20 electrons. Nitrogen is number what in the periodic table?
11.
Nitrogen, no, nitrogen. 11 is for sodium, Na.
7, 7.
Yeah, so nitrogen is 7. So is this 20 not too much?
So I thought it was um number 10. Sorry.
Nitrogen is 7 in the periodic table, right? But then we are not dealing with just nitrogen, we are now dealing with nitrogen that is charged. So
Okay.
if nitrogen is normally 7, this time around it now having a -3 charge. What effect does that -3 has on the 7 electron it normally would have for a neutral atom?
Plus 2.
It means what?
It has gained 2.
Very good, that's gain 3. So since nitrogen is normally 7 before, 7 electron before,
Yes,
then
ma'am.
nitrogen -3 means that it has gained 3. So it's now going to be 7 plus 3, which is now equal to 10 electrons. So this nitrogen -3 has 10 electrons, no
Yes, ma'am.
longer 7. All right. So the configuration will now be what?
2, 8, 2. No, 2, 8 finish.
2 8. That is it. That's very good. Now the next one would be All right. The next is, what is an acid salt? We have different types of salts, right? We have um we have acidic salt, we have basic salt, we have normal salt, we have double salt, we have complex salt. Now, an acidic salt is a kind of salt that is formed when the replaceable hydrogen ion, okay, is not totally replaced. It's only partially replaced, okay, by a metal or ammonium ion. So the hydrogen in the from the acid is not totally neutralized. All right. And so
Okay.
we will still get hydrogen being present in our salts that is being formed. That's what acid salt is. So an acid salt can go through further reaction to become normal. Do you understand? So do you have any questions so far?
No, the only question I have is how can I watch that previous video about the first thing you treated in this topic to into this class?
Don't worry. I would I would tell Lothar to like put you through personally, because
Okay, thank
okay, let me see. Let me, can you see my screen?
no ma.
This is this is, can you see my screen?
Yes, I can see it now.
Uh-huh. This is, now this is the Sismo platform. You can just go there, you put in your email, you put in your password, okay, and then you sign in. When you sign in, I feel like every other thing you'll be able to read and go through it. If it is still confusing to you, you ask questions in the platform. They will tell you how you see each of the videos one after the other. All right.
How can I get this link? This is more.
All right. The link. I don't know. I don't think the link for tutors is the same with link for you people. But I would ask the admins, and I will